just recording this lecture 2.1 on supplying power. So chapter 2 and the lab 2 are about circuits and their measurement. So first of all, we need to supply power. So in the lecture course, we've seen that we typically use two ideal models of power supplies or sources: voltage sources and current sources. In this lecture, we'll survey actual devices used to supply power. It's worth noting that there's typically a distinction made between supplying power and supplying signals. The latter are usually voltage of a specific waveform, but limited in current. In other words, devices that supply signals typically can't be loaded, otherwise they don't function properly. DC power supply. So that's the first sort of subgenre of power supplies that we'll discuss. A DC power supply is an instrument that provides DC, or constant voltage, or current. We call such, to a circuit. These devices are sometimes active and use feedback to hold their outputs at a specific voltage or current. We call such power supplies regulated. Note that regulated supplies can be treated as ideal sources, voltage or current sources, whichever is applicable, within their power specifications. But if you leave those power specifications, they're no longer ideal. We will be using the RSR HY3005 regulated power supply with front panel shown in figure 2.1. So each of the lab stations has one of these at it, and the manual for it can be found at that link. So I encourage you to look through the manual. It's a pretty short manual. See the power button here. It's got the return path ground, the chassis ground, and then the hot terminals there. You can use jumper wires to connect. If you unscrew them a little bit, there's a hole in them, and you can insert the pin of the jumper wire in, and then screw the hole back down. Or you can use banana connectors as well to connect to these. The voltage and current knobs are there, and I have a little description of how to start it up in a voltage supply mode. So if you want to use it as a voltage source, use the following procedure, beginning with the power button in the off position, so it's toggles, so have it off, and nothing connected to the output terminals. First, turn the current, fine, and coarse knobs completely on clockwise. So maybe unintuitive to do that, but that's the step. And then toggle the power button to on. Then adjust the voltage, fine, and coarse knobs until the desired voltage is generated, as shown on the display. And step 4 is to connect the plus and minus terminals. Optionally, you can jumper the ground and minus terminals as well to each other. Okay, so that's DC power supplies. The ones that we use they're pretty standard benchtop DC power supplies. There are other types of DC power supplies. So if you're going to do something that's not in the lab, then you need to have a DC power supply that is going to work for your product. So you can buy ones. Typically they're not adjustable, and they're often not regulated either, the ones that you put into products. So it's important to recognize that this is a special sort of benchtop DC power supply, and that in general they don't all behave quite as nicely as that one. Okay, function generator. A function generator is a device that generates a voltage signal. Most of these devices can produce sinusoidal, square, triangle, sawtooth, and other signals. The frequency and amplitude of the signals can be adjusted as well. Function generators are typically not regulated. Their outputs are typically BNC connectors with 50 ohm output resistance. Therefore, a function generator should be modeled as an ideal voltage source in series with its output resistance of typically 50 ohms. The nominal voltage displayed on the front panel of the function generator assumes some specific load, typically either 50 ohms or an infinite resistance. When working with a function generator, either consult the manual or measure its actual voltage output. So we're going to talk about this in a minute. This is our Tektronix. We'll be using the Tektronix AFG 1062 function generator with front panel shown in figure 2.2. So this one, notice that 50 ohm load it's displayed on the screen that it's assumed. It does not always say that on screens of function generators, but we just happen to have a nice one. We've got the selector of the type of function down here, so you could go sine wave, square wave, ramp, pulse, arbitrary, which means you can program in your arbitrary function shape that you want to repeat over and over again, and then noise. So these are the different types of functions that you can have it produce, and it allows you to set the frequency and the amplitude. Notice it's using VPP, so that's volts peak to peak. If it was a sine wave, then volts peak to peak is twice its regular amplitude, so it's that height. That's VPP. And notice that this 5 volts peak to peak, it's assuming a 50 ohm load. So if you connect something that's not a 50 ohm load, it will not in fact produce 5 volts peak to peak. So here are the two outputs. So you connect these channels. I sort of gotcha with this is that it kind of looks like these are on even when they're off. So if you're having a hard time getting the signal, press that button for the output and it'll start to come out. You can actually do 2 different signals on this function generator. So it's a really nice function generator. We also have some of the older ones, these BK Precision function generators, and they work fine. They're just the user interface kind of is clunky and old, and you can change the amplitude with this knob, but you cannot. It doesn't have a calibrated dial, so you don't know how much amplitude it thinks it's providing. So you have to measure it in order to know what the amplitude actually is. And we're going to be doing that in this lab anyways, so sort of no big deal. Great. That's pretty much it. Notice that this also has a 50 ohm output. There's a lot of functions here, but essentially range and frequency are going to give you your adjustment of frequency, and then you can choose your function similar to the other function generator. You don't need to worry about sweeps. That's changing frequency in some like linear fashion, for instance. And you don't need to worry about this. The counter and trigger should be fine. And offset, just have it right in the middle. You can offset the wave with the DC offset, but don't feel well. You shouldn't do that. You have no need to do that in this lab. Great. So that is those are 2 ways of supplying signals or power to a circuit. Remember that providing power to a circuit typically means you're going to be drawing more current, whereas providing a signal, typically you are unable to drive any sort of substantial load with a signal. So oftentimes we split these off, and if you have a device that can create complex, cool signals, it can't provide power. and then you just run a signal through an amplifier, for instance, to get higher power from that signal. So, yeah. So that is how one generates voltage with sort of real lab instruments, benchtop instruments.